Okay, this is really Q calorimetry. Do you have all these equations written out from when you wrote up your lab or not? Not really? That's okay. I'm going to leave this up, and you can look at it as we go. Okay, so we're going to kind of walk through them one by one. So the calorimetry constant of the calorimeter that we use, the styrofoam cup, was determined by the college or the AP class like earlier in the year. And it has a value of what we say 13 joules per degree Celsius. So it basically holds in 13 joules for every degree Celsius that the temperature moves. So that affects our calculations a little bit. But they already did that trial and that analysis for us. Once we have our Q-cal calculated, we take C, which is 13 times delta T of our temperature. We're going to take Q of solution, and for calcium chloride, we would take S, which for all of these S values, we're going to just use the value for water, because most of the solution is water, right? The solid that you added isn't affecting the specific heat capacity that much. So we'll use 4.18 times the mass. You need to add your masses together, right? The mass of the water and the mass of the solid you added in. So it should be somewhere around 105, hopefully, right? Somewhere around 105 times delta T. So most of you said your delta T for calcium chloride was around 1.5. You're going to put in your value for that. Okay? Don't put in my values. Put in your values. Okay? 105 is from the mass of your water plus the mass of your calcium chloride. Yeah, the delta T for most groups was around 1.5, and you guys were exactly 1.5. Okay? Okay, so next is Q total. We take our solution plus our calorimeter. So this tells us what our calorimeter and our solution are absorbing. Okay? So your value for Q of solution plus Q of calorimeter is Q total.
Wait, you have to do these like under our data table?
Yeah, under data table should be where your calculations go.
Mine are like on the side.
Well, just make them easy for me to read. Is there a spot for QT in your data table? Okay, good. Next one is Q of reaction, which is just the inverse of Q, not the inverse, the opposite sign of QT. It's just telling us what the actual thing is releasing. Okay, if it was releasing heat or what. So Q of reaction is just negative of that. So it's just exactly the same value, it's just a negative version. Okay, so for Q of reaction, it's just negative whatever you got for QT. So that's an easy one. You don't really need to show much of a calculation for that, just a negative of QT.
So if your delta T, we got 0.6.
That's pretty low. Okay, it's okay. It'll just affect make your numbers a little bit smaller. Okay. Okay, the last thing that we need to calculate is the heat of reaction, okay, or enthalpy of reaction. We're going to take our Q of reaction, heat of reaction, that negative value, divide it by the moles of your solid. Just by the moles of your solid, and that should come out in kilojoules per mole. Right now, this was in joules, and we want it to be in kilojoules per mole. So that was my fault. We need to take that number of Q of reaction and divide it by 1,000 so it's in kilojoules. Okay, that was my fault. So this value comes out in joules, and then we need it here to be in kilojoules. So we're going to take your Q of reaction, divide it by 1,000 to get it in kilojoules, and then we'll divide by moles. That's my fault. Okay, the analysis part of our The analysis part of our lab is really to find what does the best job heating 20 degrees, right? Heating it up 20 degrees at the least expensive amount, right? That's the whole goal of this, is to find the hand warmer that can heat 20 degrees for the least expensive material. So we're going to analyze how we can do that. Okay, and we're going to use kind of a little proportion here. Okay, we're going to say this many grams of our substance changes our temperature this much. So how many grams of our substance can change it 20 degrees? Right? You're going to put in your values for calcium chloride, how many grams you used, how much temperature changed, and that'll tell us how many grams of calcium chloride we need to change it to 20 degrees. Right? Does that proportion make sense? If 0.5 grams of Cl2, CaCl2, changes it 1.5 degrees, how many grams would change it 20 degrees? Right? We're just doing a proportion to solve that. Does that make sense? Okay. Use that to find out how many grams of CaCl2 you would need. Go ahead and calculate that. The mass of just the calcium chloride.
How do we convert our delta heat?
Okay, so to find how much I need for 20 degree change, I take my grams of calcium chloride divided by my temperature change, right? That's grams divided by delta T, and I get maybe somewhere around 60 grams, right? That's made up numbers. Okay? To find out how much that's going to cost me, I just do another proportion. And I look at my chart on page 101 of my handout. Do we see that chart? Calcium chloride costs $6.55 per 500 grams. And so how much money is it going to cost me if I need 60 grams? Right? Do we see that proportion?
Is this in grams? Is our answers in grams?
Our answer will be in money for this one. This answer was in grams.
Okay.
Grams, yes.
Should it be around $1.02?
It should be, a pretty low number in terms of money. So mine came out to be $0.786, right? 78.5 cents. That's what mine came out to be, if I use those numbers, which are made up.
And we're trying to find for 500 grams?
Yes, because that's what this says. It says if I use 500 grams, cost per 500 grams. That's where that came from.
Do you use the variable answer of that one for this one? Put that in?
This answer goes down here. Okay, so you've got your calculations all done. The analysis section is where you're going to tell me, so you've got your calculations for one of them all done. Now you've got to do it 3 more times, okay? Let me show you what the analysis section should be like. Okay, so with analysis, you need to tell delta H for each chemical, how many grams of each, what's the cost of each, and then she had to arrow up here, but which substance is best. A little bit separated so that I can grade it easily, so I can see it clearly and easily. Okay, are you ready for me to switch back to the calculations page so you can start working on your other ones? Not quite? Okay. Okay, so I have everything here at the top for our Q calculations and then our proportion calculations at the bottom with an example over on the right. So you need to do these for all 3 of your other substances.